This meeting is being recorded.
Okay, so in yesterday class, we were discussing about port channeling, and we were discussing about link aggregation protocol. And we also discussed about what is a static bonding. And also we discussed about what is a port aggregation protocol, PAGP. And also we discussed about the first hop redundancy protocols, FHRP, and types of FHRP are HSRP, VRRP, and GLBP. We started talking about HSRP yesterday, and we did not go to the VRRP. That's where we stopped. So let's quickly ask some questions about the yesterday class. I see Aruna. Can you tell me difference between static bonding and LACP?
Actually, I didn't go through the recording today. Sorry, I had some other. Yeah, excuse me, only for today, please.
It's okay, no problem. That's fine. Anyone can answer that difference between static bonding versus LACP?
Sure. So coming to the static bonding, in static bonding, we manually configure the modes onto the on stage, so that the communication can happen between two switches. Where coming to the LACP, that is the open standard one, and here the modes will negotiate between them, so that the modes that we use are active and passive. If in case one mode is passive and other mode is also passive, then the traffic will not flow through that. And if it's active and passive, and the flow is the traffic will flow. And if both the modes are active, then also the traffic will flow.
That's perfect. Thank you. Yeah. So the major difference is in the static bonding, it does not negotiate the parameters, and it is manually bonding them into the port channel. Whereas the LACP, we are negotiating the parameters between both sides. LACP is negotiating on both sides, and if the speed, duplex, and the configuration matches, it put that in the port channel. And like Sai Shri said, there are different modes like active and passive. If both sides are passive, the link does not come up and participate in the port channel. But either active passive or active active, the traffic will flow. They will be participating in the port channel. And Hari Prasad, can you tell me what is the big difference between PAGP and LACP?
PAGP is like Cisco support, and both do like negotiation.
Correct. So PAGP is Cisco proprietary. Only Cisco devices will support it. No other devices will support the PAGP. Whereas the LACP is open standard. So any device, be it Cisco, Juniper, Palos, Arista, Aruba, any vendor will support it.
But both do negotiation, right?
Yes, they both do negotiation. Correct. Both are dynamic protocols.
But this topic is completely confusing to me. I don't know.
When you mean confusing, any specific criteria?
No, I don't know. I will go through recording again.
Yeah, okay, yeah, please do. And if you have any questions, we can talk a little bit more when we do a revision. Maybe after mid of the course, we can do a revision class with the topics. We can high level go again. But go through the recording again and also answer my questions that I will send it to you, right? So when you are answering them, you will try to research more, and then you will learn more on that.
Yeah, I will get better idea by researching. I think
yeah,
so.
Correct. Yeah, but by that you can get more on that. Okay.
Okay.
Let's move on to Nagarjuna. Can you tell me, when do you use redundancy protocols? What is the reason behind using the redundancy protocols?
Actually, I was absent yesterday. After this class, I will listen to yesterday's class.
Okay, thank you. Can anyone answer that, please? Why do we use redundancy protocols?
To have a backup.
Yeah, so to have the backup, if one device go down, we have backup as another router. For example, let's say there are two gateways. If one gateway go down, there is a backup as the default gateway. So we have redundancy, meaning like we have active and backup as the support the network. So if one goes down, we have redundancy on the other router. That's why we use the redundancy protocols. Shruti, can you tell me the different protocols of redundancy?
Yeah, the first one is HSRP. It is hot standby routing protocol. The second one is VRRP, virtual router redundancy protocol, and the third one is GLBP, gateway load balancing protocol.
Thank you. That is correct. Okay, Sudhir, can you tell me what is the difference between GLBP and the other two protocols? What is the major difference between them?
I'm sorry, sir. I have absent for last class, but I have gone through the recordings. But I'll try to say it. GLTP we use gateway load balancing protocol in the like gateway IP address in the router 1 and the router 2.
So what is the big difference is the GLBP can do load balancing. So it at a point of time, both the gateways can act as active. It can do a load balancing, but the other protocols cannot do the load balancing. They can just do as active and backup. Think about like this. Let's say there is a coffee machine in a shop. If that coffee machine fails, you have a backup coffee machine that is sitting ideally, but it's not serving the coffees to everyone. But think about two coffee machines working simultaneously to give coffees to all the customers. So that is GLBP. A GLBP can serve both the routers to send the traffic in and out, but the other two protocols cannot do that. It waits for other to fail and then only it will take over the role. We'll discuss more on that today. So let's move on to today's topics, guys. I know there is inconsistency, guys. So some of them are not joining every day. Some of them are not following correctly, but please try to catch up. Otherwise, you will miss the continuity of the class. I don't want that. When you join the class, at least to respect your time, please do some research of the previous class and come back. At least you will understand. Otherwise, it's just waste of your time, guys. That's why I'm saying. But please try to follow what I'm saying. Along with that, try to come up with reading the recording of the previous class. Okay, and now let's do the whiteboard. Okay. Do you guys see the whiteboard? Yes, no. Anyone see the whiteboard or no?
Yeah, yes, we can.
Yes, we
Okay.
can.
Okay, cool. So let's talk about HSRP, VRRP, and GLBP. So active, standby, master, backup. Gateway. Active gateway. Active gateway. Switch 1. Switch 2. I mean, any switch numbers are fine. So switch 1 again. So in this case, guys, PC1 is trying to go to internet. PC1 is going to internet, and PC1 is trying to go to the internet. So the topology of the networks are same, but the protocols we are using for the redundancy are different in each case. So if you see the names, the naming conventions are different. In HSRP, it is called active and standby. In VRRP, it's called master and backup. In GLBP, it's called active gateway and active gateway because the GLBP does the load balancing between these two. So how does the PC1 knows how to go to the internet? The PC1 will know to go to the internet to go via its gateway. So on the PC1, we configure 3 things. We discussed this in the yesterday class. So the 3 things that we configured on the PC are: 1 is IP address of the PC, 2 is
Gateway
IP, and 3 is subnet mask. So we configure these 3 things on the PC1. So in this case, I want to configure my gateway IP as the HSRP IP. That is called HSRP, virtual HSRP, virtual IP. So in this case, let's say the IP address of the PC1 is 10.10.10.10, and the virtual IP is 10.10.10.1, meaning this virtual IP can be configured on 2 routers. This router, it can be configured on this router or this router. So 10.10.10.1 is configured on here and also here, right? When the PC1 to go to the internet, it has to choose either this router or this router. In this case, I want to choose this router. So what I'm going to do is I'm going to put the priority higher on this router. So the default priority is 100 in HSRP, right? So I will make that 100 as maybe 120. And this priority will be 100. And there should be a link between both the routers to communicate the HSRP priorities and HSRP hellos. So they communicate using the link between both the routers. They exchange the priorities between them, and they both will send the IP address of HSRP active router pointing of its MAC address resolution to the switch 1. So the switch 1 to go to the gateway, it will always point to the active device MAC address. It will not choose the standby MAC address, because as you guys know, switch does not care about the IPs. It will care about only the MAC addresses. So for the PC1, the destination IP will be 10.10.10.1, but that will be resolved into which MAC address? The router 1, the active router MAC address. So you guys know, because when the PC1 does not know what is the destination, what does it do? It will send the packet to the switch 1, and switch 1 will do the broadcast. And that broadcast packet will be getting response by the active router that I am owning 10.10.10.1 because I have the higher priority. So from the next packet, it will be what? Unicast. Now the PC1 will know how to go to the router 1, and the router 1 will go to the internet. So always HSRP works on active and standby. The active one will have more priority than the standby router. If the active router go down, the standby router will take over the role, because there is a link between them and they both communicate using hello messages between both the devices, and they also exchange the priorities. So what happens when the active router go down? How does the switch know that the active device went down?
Using the HSRP protocol, there will be a link between the active and like standby. So if active goes down, the standby will be the primary one now, and it will send the update to the switch.
And what is the update called? Yes, that update is called. Yeah, I did not.
Priority.
No. The priority is, yeah, I think Sai Shri nailed it. The active one failed. They both communicated, and the standby one will say that update to the switch 1, and that is called gratuitous R. Let me write that down. Just have to change the settings again. Hold on 1 second. Okay. Yeah. So it's called gratuitous ARP. So what does gratuitous ARP mean? Whenever there is a change between the gateways, the gateway will automatically update to the ARP response saying that, hey, the active router went down. I am your active router. I will be responding back to you for this 10.10.10.1 IP. That response is called gratuitous ARP. You guys already know what is ARP. ARP is nothing but mapping the layer 3 to layer 2. But that update packet is called gratuitous ARP. That you are updating that there is a change in the active to the standby. Okay, next question. What happens if the active router comes back up? Let's say active router went down and it came back up. Will that take the active role back, or will
it will become standby?
I'm sorry.
Then the roles will be changed. I think active one becomes standby, and standby will become active.
Even though the active router came back?
Yeah.
Why?
Because
the active router has high priority, right? It came back. So will that not take over?
I mean, like the standby is anyways working, right? Like,
Yeah. So standby is anyway working. Why do we need to change the network back, right? Why do we need to fail over again? Why do we need to have one more outage, right?
Yes, yes,
So
yes.
in that case, yes. But what if I want to make my active always active? I'll tell you, I'll explain the reason again. Hold on, let me tell you why. Let's clean up things here. Let's say this is 1 gig internet link, and this is let's say 100 meg. So this is 1 gig link. This is 100 mega link. I don't have that budget to procure both the links as same. So that's why I always want my path to go via this way. Let's say this router went down. Until then, okay, I'm going via this path via 100 meg link. But I don't want this always staying active because I have my 1 gig link, which I'm paying more. For example, 1 gig link costs me $2,000, $2,000. 100 meg costs only $500. This has the higher speed. So I always want this router to be active. When it comes back up, it should take over the role of active because I want to prefer this link to go to the internet. In that case, what we do? In that case, this should be active, right? Do you agree now?
Yes.
Yeah. So if we have use cases like this, there is a concept called preempt. Let me write that down. Preempt. Preempt means you are basically saying if a router go down and if it comes back up, if it's having the high priority, it should automatically fail it back to the active router by sending the gratuitous ARP. So whenever the router 1 go down and comes back up, if it has the high priority, it should automatically become the active again. So this router should say to the switch that, hey, I have more priority than standby. I came back online. I am the boss. For that, we do the configuration called preempt. Okay. So what do we do, guys? We will create a virtual IP and we will define the preempt. And there is an issue with the preempt. What happens? Just undo this. Okay, so what happens if this router keep on like going down and coming back, going down and coming back? What will that happen? So then if that's keep on happening, if this router going down and coming back up, then what happens? The HSRP keep flapping. So this one will become active and it comes back up. This one will become active and again it goes down. So there is a lot of network flapping going on. And what does it cause is the PC1 will not know whether to go via this path or this path because the roles keep changing and you have a network outage. So how can we prevent that? How can we prevent the router 1 when it's flapping? How can we prevent with the preempt? Any ideas? So if the router keeps flapping, what we have to do is we have to wait 5 to 10 seconds to make sure the router is settled. If it is up for 10 seconds, then only take over the active role. If it is not up for 10 seconds, then don't take over the active role. You stay as standby. So we configure the preempt and the lifetime of the preempt. So if it stays for a certain period of time active, the active router comes up, and if it stays up for certain period of time, then it will take over the master role. If it keeps bouncing, if it keeps failing, then it cannot claim the master role. That is what the preempt time is. Clear, guys? Any
Yeah.
questions with the gratuitous ARP or preempt? Okay, I'll take that as a no. Okay, moving on to the VRRP. VRRP is saying the master and backup, they both communicate between them. There is a priority setting on the VRRP. So if master will have high priority, then the backup. If the master go down, the backup will take over the role. VRRP also supports the gratuitous ARP. It also supports the preempt. So if the master go down and if it comes back up and if it waits for a certain period of time, it will take over the master role. What is the big difference between HSRP and VRRP? HSRP is Cisco proprietary. Cisco. VRRP is open standard. Like any vendor can support the VRRP. There is also one more difference between HSRP and VRRP, which is important. That is a gateway IP is shared between both the routers in both the protocols, correct? So for example, 10.10.10.10.1 is shared between both the routers, but there is also interface IP. Like for example, the interface IP can be 10.10.10.2. And this interface can be, IP can be .3. In VRRP, this virtual IP can be reused to the interface IP. Why this is needed is when you are running short of IPs, you can use one more extra IP on the interface IP along with the virtual IP in the VRRP. But in the HSRP, the virtual IP is different, the interface IPs are different. They cannot be shared. But in the real world, honestly, no one will use the same IP. There is no shortage of IPs. And because we already have an IPv6, we can use them if needed, but it's not a good idea to duplicate the IPs in any of the network. Even though it supports, always try to use a different IP for the virtual IP and a different IP for the interface IP. But just to understand the difference, I just mentioned that you can reuse that IP in the VRRP, but the HSRP does not support it. Even if it supports it, when you're working in the real time, don't do that. And one more difference that we can think of when we are talking about HSRP and VRRP is the terminology. Like I told about active standby, master backup, the terminology is different. And also in both the protocols, the load balancing is not supported. This one cannot support load balancing. This one cannot support load balancing. Both HSRP and VRRP, they both does not support. And now let's talk about the GLBP. GLBP, on the other hand, it does support load balancing, meaning the traffic can go via this way and the traffic can go this way. There is a link between them. How does this work? So both the gateways will talk between them using hellos again. And there is a load balancing mechanism called round robin. Have you guys know what is round robin? Round robin is like, let's say you are in a casino. There is a dealer and there are 4 players playing blackjack or any of the game. this dealer will be giving the first card to this guy, second card to this guy, third card to this guy, and fourth card to this guy, and repeats the same thing to this guy. So he is equally sharing the cards. Maybe let's say you are playing Uno. Maybe if you guys play Uno, you give one card to one person and repeat that process until your cards are finished. For example, if you are doing like set of 5s, you give first card to this guy, this guy, this guy, this guy, and repeats, right? Until you complete for all of them, you will share one card to the other. That is the concept of that is called round robin. Similar concept. So here there are 2 routers here. So the first packet goes this way, second packet goes this way, third packet goes this way, fourth packet goes this way. That is called round robin. That is the mechanism. That mechanism is called round robin load balancing mechanism. So in this case, like we discussed, the IP address of the PC1 is 10.10.10.10, and the gateway IP address will be 10.10.10.1. So both the gateways will have the same IP address, but they both share their virtual MAC addresses to the switch. So they will talk between them and prioritize which MAC address to respond to the switch. So the switch will send that to the virtual IP of the gateways. For example, I want to draw this again just to make it clear for you guys. So give me 1 second. So let's talk about that. I don't want to make it confusing for you. So let's clear this. So let's say there is a switch 1, I mean router 1 and router 2, and think for a second that these are part of one cluster or one nested group, and this nested group has an IP address of 10.10.10.1, and let's say that nested group IP will be pointing to 2 internal MAC addresses, MAC address 1, or IP addresses, or let's say IP address 1. For example, this can be 10.10.10.2. I'll do .2, and this one will be .3. And there is a switch, and there is a PC. So when you point your default gateway, you will obviously point to this 10.10.10.1, and this 10.10.1 is the GLBP gateway IP, and this GLBP IP can either point to 10.2 MAC address or 10.3 MAC address. It can send one packet to 10.2 and 10.3. So the responsibility of the PC is to send that to the 10.1. That we will do it by configuring manually the gateway IP, and the GLBP protocol will load balance between them by sending to both the routers. That's how the GLBP sends the traffic to both the gateway routers. So if this guy fails, for example, this guy fails, this will know that the .3 failed. I should always pass the traffic to .2. Similarly, if this guy fails, it will send the update packet to 10.1, and okay, so then the traffic will go via this. If both of them are up, they both will be listening between them, and this dotted one can send the traffic to both and they can go out. So that's how the GLBP works. GLBP works on load balancing mechanism. So the PC will point that to the gateway of the gateway IP, and the gateway IP will be pointing that to the both the routers with load balancing round robin. So there are different mechanisms, not only round robin, there is also like weighted round robin. Previously, we discussed about having a 10 gig link here and talked about having a 100 meg link here, right? In that case, what you can do is you can do weighted round robin. What does weighted round robin means? So for example, similar example, you are playing, you are sharing the cards to 3 guys. So you are giving 2 cards to this guy, 1 card to this guy, and 1 card to this guy. And next round, you're giving 2 cards to this guy, 1 card to this guy, and 1 card to this guy, 1 card to the third guy. So you are doing a weighted round robin. So you are giving priority to 1 guy over other 2 guys. Similarly, when you do the weighted round robin, you will send 2 packets to this, 1 packet to this, because you have more capacity to go out to the internet via this link. You can prioritize that. And the third one is host dependent, meaning let's say this PC, there is another PC, and there is another PC. So based on the MAC address PC, this PC traffic can always go through this switch. This PC traffic can always go through this switch. So this is called host dependent. So based on the endpoint, there will be a hash value that is defined on the gateway, and this gateway will see, okay, it's coming from this PC. Let me send the traffic to this. Why this will be useful is, let's say there is a video server. It is streaming 10 gigs of data. If we send this 10 gigs of data via this link, this cannot handle that. So what we can do is, we can prioritize a hashing value to make sure this video traffic always go via this PC. This router. In that cases, that mechanism will be working on the GLBP. So the configuration wise, you don't do much. You will go to the GLBP interface. You will put round robin or weighted round robin, or you will do host dependent. That's the keyword you will use. And the protocol will know that, okay, we are doing host dependent. So every host will be defining certain path to go out to the internet. That's what you will do. But I have never used host dependent anywhere because it is not that effective. Host dependent is really not in your control. It's the GLBP control. So it does not really send your traffic the way you want. Either you will use round robin or you will use weighted round robin. Those are the most used ones. And you guys already know the HSRP and VRRP. We use preemption and the regular priorities. Any questions there?
Okay, so while we're sending the packet, like the first packet, so to select the router, is it selected like randomly, or is there anything that we use over
Just
here
a random,
to
just
go
a
to
random.
the-
It does not mean that it has to go via router 1 and router 2. It's very random. You can either choose one,
Oh.
you can either choose 2. That's it.
Okay.
Yeah. There is a concept called hashing. If you guys know, I don't know how many or you remember AND operation OR operation, XOR operation. If you guys remember, maybe in your BTech days, there used to be a table like A, B, and if 1 and 1 matches, you'll get an output of 1, 1, 0 matches, you'll get an output of 0. There is an operation like this. Similar operation will be done by the switch. If the packet is coming from PC1, if the packet is coming from PC2, it can choose either 0, first packet, or 1. So there is an operation that is called hashing value. That is something that is done at the ASIC level. But as an engineer, we don't care how the switch is forwarding that packet. That is something that the electrical students will do. As a network engineer, we don't care which link it uses. All we care is whether the packet received by the other end or not. But to your question, it uses something like this operation to choose which link to go or not. Which link to choose, whether to choose 1 or 2.
Okay, got it. Thank you.
Yep, no problem. Any other questions? So the purpose, the main reason is always to have the network up and running. We have to make sure that we have redundancy in the network. For that, we use these redundancy protocols to have failover mechanism easily. Like if one go down, you have a backup without you manually intervening and trying something. That's why these protocols are important, and we use that on every daily network. Anywhere you see, you will see them. And if you want to look into the real-time configuration, let me let me show you how does we configure the HSRP or VRRP real quick. Let me stop share that. Okay, so I'm logging to one of the device, a router. And okay, so I logged into one of the interface. This interface is a logical interface. We can talk that more when we talk about layer 3 routing, but just think it as an interface. And if you see, I configured the preempt delay minimum, meaning like this device has to be up for 5 seconds at least to take over the role of the primary. And the priority is 105. The default priority is 100, and this device priority is 105. And the IP address of this HSRP is .1, and the interface IP is .2. The HSRP IP is .1, and the timers are like hello and dead timers. Like for example, I send the hello to my HSRP peer 2, like the router 2, for every 1 second. If I don't get the response back in 3 seconds, then the roles will change between the primary and secondary. This is called the timers. I think I missed pointing the timer. A timer is nothing but when both the HSRP routers exchange the hellos, how much time I should wait for my router to down or up. So that is the timer. So first is the hello timer. For every 1 second, it sends the one hello packet. And if it does not get in 3 responses in 3 hellos, then I think that my neighbor is down. So that is this is the version. HSRP version 2 is the latest version. Previously, the version 1 is there. That version 1 is depreciated. It's no longer supported. In version 2, they added something called authentication. Authentication is nothing but we are adding a security feature where I will recognize my neighbor with the specific password. If the password does not match, my both routers, the HSRP router 1 and router 2, they both will not communicate each other between them. So in version 2, they added the HSRP password between both the routers. It's something that it's not mandatory. It's something that it can be used as a feature. But that's how the HSRP configuration looks like, guys. Any questions there? Okay. So for today's class, we discussed about different redundancy protocols. We discussed about what is HSRP, what is VRRP, and how do we use the GLBP in the network. So let's do a little quick Q&A. Ritik, can you tell me what is the big difference between GLBP and other 2 protocols?
So in GLBP, the switch sends a package to both the routers, and both the routers are very active. And in HSRP and VRRP, the only one is primary, other is a backup. And in GLBP, that both are primary and both are active.
Yeah, so you can use the load balancing. Both can be active. Correct. Yes, that is correct. Lakshmi, can you tell me what is the setting of preempt?
So whenever the router goes down and it come back, if it has a higher priority, it should automatically turns into active.
Perfect. Thank you. So spot on. So whenever the router goes down and comes back up, it should take over the role of the primary because there might be a reason that it has more capacity than the other. So that's why the preempt works for that router. So preempt is used. Okay, that's good. Monica, can you tell me what are the roles of the routers in the VRRP?
One router is selected as a virtual router master and other as a backup.
Correct, perfect. So in HSRP, we call it as active and standby. In the VRRP, we call it as master and backup. Okay. Let's see. Varun, can you tell me why do we use a concept called gratuitous ARP?
Okay. So I mean, like when one goes down, when one router goes down, so I'm just like just give a second. I just forgot I wrote, but I
That's okay. Let's pass it on to Shruti.
Okay, so it gives an update to the switch when the active router goes down.
Yeah, so if one router go down, to update that the role change, the ARP entry will be notified saying that it's no longer the active router, the other router took over the role. So the update will be sent, the ARP binding will be changed to the backup router MAC address. That is called gratuitous ARP. Okay. Why do we need link between both the routers? Why do we need that link between both the routers? I think Mahit, why do we need the link between both the routers?
To communicate between them.
Yeah, so using the link, both the routers will communicate and they will exchange the hellos. And if that link goes down, what will happen?
The communication will be ended.
Yeah, if that link go down, both of them cannot exchange hellos, and there is a concept of split brain, meaning both of the routers will try to become active, and that will cause the network downtime. We don't want that. That's why we will use port channel to make sure that we have redundancy of links between both the routers. So that's it. I think that's a good segue to stop there. Let me stop the recording.